Welcome, ma'am. Of Technology and Science to share her findings and opinions on today's topic. Welcome, ma'am, and I thank you for accepting our invitation, ma'am. With equal pleasure, I welcome guest speakers of other sessions as well, and I sincerely appreciate them for taking time out of their busy schedule to share with us their valuable insights on the ever-evolving field with the new technologies, tools, and methodologies emerging frequently. I feel glad to extend a warm welcome to our additional registrar, Dr. V. Cyril Raj, who has always been a moral supporter behind all our accomplishments, which helped us maintain our enthusiasm. Welcome, sir. My hearty welcome to our Dean Engineering and Technology, Dr. N. Ethiraj, who has always been our pillar of strength in all of our efforts. I feel delighted in welcoming all the faculty members from various academic institutions and host institutions to utilize the platform to upskill their knowledge in the specified domain. I would like to thank the event coordinator, Dr. Chunchu Rambabu, who was an integral part in organizing this FDP. Once again, I welcome you all to the event and I'm confident that you all will have a productive learning experience at the end of this 6 days faculty development program. Thank you.
Wherever she goes, a woman of value adds value. She so is our Honorable Vice Chancellor Dr. S. Geeta Lakshmi. Now, I request our respected Vice Chancellor to deliver the presidential address. Ma'am,
Yes, baby Rama, I'm just checking out. Just few minutes.
Ma'am, it is not audible, ma'am.
ma'am, is VC ma'am there, ma'am?
இப்போ கேக்குதா?
Yes, ma'am. Your voice is audible, ma'am.
Yeah. So thank you because well, something I denied something and edu ஆயிடுச்சு. A very good morning to all the 6 day for the EC department who has conducted, which is the necessity of the day. the VLSI design in the EC department, which is a requirement nowadays for the advancement in the computer science technology. So, which is a part of this electronics communication. And I would also thank the Dr. Jayalakshmi and her team who had made it possible for a 6-day event. Really very hard working, you have done a hard work to make this possible for 6 days, to invite very good speakers for this program. And the effect of it should be that we should also follow those whatever deliberations and the knowledge we have acquired on these 6 days program, to see that we also develop these kind of new technologies in our own department with the available funding, and the requirement for funding can be applied. And I also want the students and the faculty who are into this program to also understand and to explain them and get ideas from them, still more to develop. And I think so with this 6 days program, we should not just keep quiet. We have to follow it up. And I thank all the guest speakers who have come here for the 6-day program to give their experience in their work field to our faculty and students, and what are the difficulties undergone by them, so that these difficulties can be overcome by our students and faculty, and a new program can be made. I think so this VLSI design is the requirement of the day. So thank our management and the department who has toiled a long time for making this possible. Thank you one and all.
Thank you, ma'am. Thank you very much, ma'am.
Thank you, ma'am. Now, I request our additional registrar, Dr. Silraj, to felicitate the event.
Uh, Respected Vice Chancellor Madam, with profound thanks to our Founder Chancellor Sir and then our President Electronics Communication Engineering Department to have such a very important workshop, faculty development program on VLSI. Dear friends, all of you are aware, though we claim that our country has knowledge capital or IT we are largely depending on a small country like Taiwan for all our hardware. We are totally depending on China, the mainland China for all our the hardware requirements. I think the rivalry between the American hardware industry and then the Chinese nuclear, how it has affected our GDP also, all of us, we are aware. The reason behind is the way that actually we are concentrating on the software, we are not equally giving importance for the hardware design, especially the VLSI. Dear faculty friends, if you see that type of opportunity available for VLSI, it is tremendous. That too, with the development of IoT, that is, IoT and VLSI, and then with the other developments right now, there are a lot of research happening there with less than 1 micron also. So right now, our transistors would able to bring down the size with the 3 micron, but right now with the less than 3 micron, so definitely more within less area, more components, and then the power management, and then the design, testing. So all these things need uh, definitely uh, well qualified VLSI designers, testing professionals. So the demand is very very high. Even fresher starting salary, it's around 8 lakhs per annum also. So in such a situation, meeting out, I mean, all the required human, I mean, manpower is very, very important at this stage. So the faculty program, faculty development program like this will enable to concentrate more on the three important aspects of the VLSI, the design, and then the physical design engineers. All these things, I mean, are very, very important. So if you see the type of opportunities, it is $500 billion opportunities available, awaiting for us. So hope, especially I mean, state like Tamil Nadu, it has started attracting, I mean, many hardware industries. So definitely we need more and more the skilled people on this particular domain. So please make use of this opportunity. I wish all the participants a grand success.
Thank you, sir. Thank you very much.
Thank you.
Now I request our Dean, Dr. Etraj, to kindly felicitate the for the event.
Good afternoon, all of you. Respected Vice Chancellor Geeta Lakshmi Ma'am, respected Additional Registrar Vlsi Design Sir, respected HOD EC Dr. Jayalakshmi Ma'am, and all other faculty friends. I first of all wish to congratulate the EC department for conducting such a advanced technology topic to enhance and get to know about the technology to the faculties. Actually, we know that VLSI, how far it helped us to innovate and design a compact and miniaturized products. See, actually, basically I'm a mechanical engineer, but fortunately I had an opportunity to start my career in the electronics industry only. It as a manufacturer of electronic push button telephones. The size of the telephone, what you see on the desktop, and it contains a PCB, printed circuit board, which is only a single layer. It contains all the resistors, capacitors, diodes, even some of the ICs are there. Three ICs are there. One is for transmission and distribution, another one is for dialing, and another one is for ringing. So nearly about 300 components are there in a single layer. And when I visited in HTL, Hindustan Teleprinters, I saw two double-sided. That's the maximum extent we have seen. Now you can think of what is the advancement happened in VLSI, where we have so many layers are there. So in each layer you have so many thousands and thousands of components are there, and each layer is performing a different function, and it is feeding the other layer also. So like that, the advancement is really miraculously happened, and nowadays it's very compact and very small. Actually, all the products have become, what is the size of the computer, the desktop computer before, and what is the size of the desktop computer now, and what is the size of the what is a mainframe used in IIT. You can see there, very big, and it occupies a very large area. And now you can't think of such a big size, so you can see only very small, compact and miniaturized products only. So this is possible only because of this type of designs, and it is a really challenge. Because we know that even when I was there, we used to make PCBs on our own, indigenized. During that period, we found it very difficult to design and do that, because you have to design it in a enlarged scale and then bring it to the smaller scale, print it against the board, all those things. Now just imagine coming to a very small, where you have to embed all the components, or you have to form the security. All those things are a real challenge. So this technology has given a big challenge towards us, and still in the future it is going to still more reduce, as AI was telling. Uh, it is going to be very yeah, thin, and it is going to be in microns. Another one important thing is actually we are very unfortunate enough that we are solely depend for electronics components, whether you take it, whether it is for computers or for drones or for robots or for any machines. We are depending solely on other countries, unfortunate enough. But actually we are supposed to make our own indigenized components. I don't know what is the reason why we are not able to go into that field, because I know that when since I was in the electronic industry, during that period only two people are there manufacturing the chips. One is a semiconductor device Ariana, and another one is a SPIC Electronic Corporation in Chennai. But I don't know speak gel is spell is there or not. I don't know. But very unfortunately now also we are depending on all the ICs and everything. We are other thing. Another main threat what is now the worldwide globally everybody is facing is a shortage of semiconductor devices, and heavy research is going on for alternative material or alternative type of electronic components. So first we should understand what is going on in the VLSI. So this FDP will definitely give you the opportunity for the faculty members to upgrade their knowledge, definitely. And once they are updated, and they can guide the students in the right path. So once again, I congratulate all of them. Thank you for the opportunity. Thank you so much.
Thank you, sir.
I now request our Professor Dr. Janaki Rani to introduce the speaker of the day.
Good morning, everyone. It gives me immense pleasure to introduce the chief guest and the speaker of the day, Professor Dr. Ushaa Eswaran. Professor Dr. Ushaa Eswaran completed her B.Tech from Annamalai University and her Masters from Andhra University in Electronics and Instrumentation Engineering. She obtained her doctorate from Jawaharlal Nehru Technological University, Hyderabad, in the field of biosensors. Currently, she is a principal and professor at Indian Institute of Technology and Science in Andhra Pradesh. She is a multifaceted personality where her expertise includes as a motivational speaker, women's rights activist, entrepreneur, educationalist, parenting coach, public speech coach, transformational facilitator, emotional intelligence practitioner, etc. She has over 33 years of experience in the fields of education, research, skill and career development. She has served as a planning board member at Thiruvalluvar University. She has held leadership positions in engineering institutions as Chief Placement Officer, Principal, Director, Dean, and Advisor. Apart from that, she is actively engaged in imparting skill and career development, empowering women, and academic consultancy through SEEK as its CEO. Over the past few years, she has conducted numerous training programs and seminars for corporate and institutions that have enriched the knowledge of participants through interaction and knowledge sharing, contributing to their improved learning and development. She has addressed over 30 lakh people by visiting various countries like Malaysia, Singapore, USA, China, France, etc. And she has conducted stress relieving, parenting, and life skill workshops for more than 10 lakhs of people through mass contact programs. And she is a recipient of many awards and recognitions. And she has received more than 10 awards. And to mention a few, she has received the Outstanding Academic Contributions Award in the field of science and technology from National Foundation for Entrepreneurship Development. And she received Best Educationalist Award and Certificate of Education Excellence from International Institute of Education and Management in New Delhi. And she is a recipient of Excellent Professional Motivational Speaker and Dedicated Academician Award from the Society of Innovative Educationalists and Scientific Research Professionals. And she received this Rex Karmavir Global Fellowship and Karmavir Chakra Award from ICONGO and United Nations in the year 2019. And she got this Women Excellence Award for HR Success Talk in the year 2021. And she is a recipient of Dr. APJ Abdul Kalam Best Teacher Administrator Award from the Association of High and Higher Secondary Schools Retired Headmasters, Chennai. And recently, she received the Rex Karmavir Jyoti Puraskar Award from United Nations in the month of November. And she is a member of professional bodies like ISTE, IEI, etc. And Dr. Ushaa Ishwaran's key project is educating children and adolescents about personal safety in schools so that they can identify and seek help in an unsafe situation. And she has been instrumental in setting up skill development centers where students are imparted with industry specific skills that enables bridging the academic and industrial skill gap. She has encouraged setting up of innovation clubs where the students are provided with opportunities to interact with successful entrepreneurs and learn from their personal experiences. And she conducts regular training programs for both schools and institutions of higher learning and also corporates in achieving their business objectives through cost effective and skill enhancement programs that are designed and customized suiting the individual needs. Her corporate training includes sessions on soft and hard skills development and attitude building. She conducts customized career development programs for schools and college going students. Apart from that, she has over 1,500 videos in her YouTube channel focusing on skill development, faculty development, new teaching methodologies, goal setting, art of concentration, work-life balance, importance of values and principles, anger management, 21st century skills, art of having presence minds, which are the need of the hour today. And she is passionate in supporting social causes and assists numerous NGOs in the state. She is also the Pink Ambassador for NGO Chennai, Chennai Turn Spring, promoting awareness on breast cancer and women-centric issues. She has been a guest speaker on various television talk shows on life skills, parenting skills, social and women-centric issues. And thank you, ma'am. I welcome you warmly for this FDP program, and we are eagerly waiting for your interesting as well as a valuable speech. Thank you, ma'am.
Thank you so much. I hope I can start the session.
Yes, ma'am. Yes, ma'am.
Okay. So, hello everyone. Very good afternoon to you all, and I would like to thank you all. I'm honored to join you at the inauguration of the 6 days virtual faculty development program on Vlsi Design. And I extend my gratitude to the Electronics and Communication Engineering Department and the EcoMet for organizing this fantastic initiative. And also, it's mandatory that we stay updated with the very large scale integration technology, which is very, very crucial. And I would like to thank all the organizers. I would like to start from the chief patrons, advisory committee members, conveners, coordinators, and each and every teaching and non-teaching who is part of this initiative, whose untiring effort will lead to a successful completion of this 6 days virtual faculty development program. So I'm very, very thankful to the president, chancellor, and the vice chancellor, HOD, EC, and especially the person who contacted me, Kalpanata ma'am, and also Ram Babu sir, who was coordinating very well for this program. So, as a guest speaker, we have a unique opportunity to exchange knowledge and ideas. So, let's make the most of the program to collaborate, learn, and advance our understanding of VLSI design together. So when we talk about VLSA, very large scale integration design is exceptionally important in 21st century. We all know that we are living in 21st century, but we have learned in some other century. So we have to keep our mind, and we have to take lot of inputs based on the requirements of the 21st century, because the students are here learning from 21st century and they are going to work in 21st and 22nd centuries. So we have to update our technology, update our knowledge, and also try to learn a lot. So let me first start with the significance, why it is so paramount, why VLSA is talked so much, because we know, like, all the students wanted to join in computer science department, and all the brainy children go into computer science department, and we don't have much of people to do the research, because this is an area in EC which is very, very essential. So even the students who join in EC, they would like to go to an IT job. So it is the first and foremost responsibility of the core department to give awareness to our students to take up core areas and strengthen themselves, so that the competition is less for them in our communication engineering department, and they have to work hard in knowing the new advancements so that they can reach higher level in a quicker time. So the importance of VLSI is mainly because of the technological foundation it lays, and also the miniaturization and performance, because everybody wanted to have a smaller sized equipment or component or whatever it is. So miniaturization is VLSI is associated with miniaturization. And also computing power and efficiency is very, very high in VLSI. And also we can say that pervasive applications, because now while talking, we have seen our Cyril Raj sir and Ethiraj sir talking more about how this is going to impact, because in 21st century we are talking about industry 4, industry 5, a lot of new technologies. So this VLSI technology is going to impact the diverse domains, including AI, IoT, healthcare, communication, automotive, aerospace, entertainment, and more and more and more. And that is one thing which we have to keep in mind, that VLSI is going to help us a lot. And then AI and machine learning. So this is also an area where VLSI is going to do a lot of work, and also connectivity and communication, healthcare and biomedical devices, sustainability and efficiency, innovation and evolution, economic and societal impact. So all these things are going to be associated with VLSI. That is why the VLSI design importance is very, very, very high, and we are talking more about it. And also we can talk about what are the distinctive aspects when we talk about VLSI. One is the complexity at scale. So that is one thing, while designing the VLSI, there we will be having such shortcomings or challenges. And also miniaturization and integration. This is where again the chips are shrinking, and the components and integrating diverse functionalities also into a single semiconductor substrate. That is going to be a challenge. And also the customization and specialization, and coming to the power efficiency focus, diverse applications, innovation in design techniques, impact on Moore's law. This is again we have to keep in mind. And also the role in specialized hardware, integration of advanced technologies. So all these things are making our VLSI the top most important line. And I'm very extremely happy that EC department has taken this as a prime topic for this FDP. So the future growth, when I have to give you a short input about what is the future growth of VLSI, here we have the AI acceleration and specialized hardware. There again VLSI is required. And edge computing and IoT, here again we need VLSI. 5G and communication technology, here we need VLSI. Healthcare, biomedical applications, here we need VLSI. Then energy efficiency and sustainability, here again, we need VLSI. Then quantum inspired computing. See, now we have to focus more on quantum computing, because this is what is going to make everything fast, fast, fast. So there again, we need VLSI. And security and cryptography. See, we are in a digital medium and we don't have security for our data. So here security and cryptography with VLSA, because the need for secure hardware and encryption systems will drive VLSA innovations in creating secure chips and specialized hardwares for enhanced cyber security measures. So cyber security is one thing which we have to keep in mind whatever we do, because we need to secure our hardware as well as the things, and also the advancements in design tools and methodologies. So this is again we have to focus on. So now I would request Rambabu sir to uh, change these slides. Can you change the slides, please?
Ma'am, your slides are not visible, ma'am. Kindly share your screen and present, madam.
I am not presenting. Rambabu sir is presenting. The PPT is with him.
No, ma'am, it is not visible. It is not shared.
I'm not sharing, sir. Rambabu sir has to
Yeah,
share.
1 minute.
Okay,
Sir,
thank you, ma'am.
I've already sent the PPT to him.
Okay, ma'am. Thank you.
Ma'am, doing ma'am. 1 second, ma'am.
okay, sir. Or if you face any difficulty, you please share to my mail. I'll share the screen.
Yeah,
Yes,
any
ma'am,
one
we are
of
doing,
you
ma'am.
can share. I have difficulty in sharing.
Okay, the screen is shared by.
Can you move the slides, please?
Yeah, it's visible.
So you can open the PPT and share this to me. Okay, in the meantime, I'll just talk about empowering faculty in easy. Why did we keep that topic in my FDP is because this is very, very important. It's not like we come and go and teach the same thing what we have taught in the previous semesters or years, because empowering faculty members is a very, very important in each department, especially when we are talking about ECE. It is very, very crucial for ensuring the delivery of high quality education, because here we have to talk about the quality education and how can we make it high quality education. So when faculty members are empowered, it has a positive impact on the overall educational experience for the students. Because some of the reasons, let me tell you why we need to empower the EC faculty. Number one, enhanced teaching learning experience, because it is not blackboard and writing on the blackboard and that teaching is all old style. We need to have a student centric environment in the teaching learning process. And even in teaching learning methodologies, we have so many new teaching learning process coming in. So the empowered faculty members are more likely to be engaged and motivated in their teaching roles. So that is very, very important, because motivation of the faculty is very important before you teach them any technology. And they will have a freedom and autonomy to design and deliver their innovative and effective teaching methods. So individually, every teacher will have their own way of teaching. So these all to be customized before we start any semester, and this in turn leads to an enhanced learning experience for the students, because the students don't have patience. They can't even sit and listen to you for more than 3 minutes. So we have to conduct a class for 15 minutes. So how the faculty will be able to interact with the students and deliver whatever they wanted to deliver, and how they will make the students absorb whatever we are saying. So here there is a challenge, and we need to change our teaching methodologies. So we have to enter into an active learning strategy and project based learning. This is to be introduced in our teaching learning process. Then coming to the updated curriculum and course content. So we need to bring all the new technologies into our content, because that MGR University, as an university, you have the freedom to bring in a lot of new add-on course or whatever is coming in the technology. Even if it comes today, you can add tomorrow with the approvals of different committees. And the empowered faculty members are more likely to stay abreast of the latest advancements. So now every faculty should have the opportunity to know about what is happening, what are the new technologies coming in, what are the new research papers published, what are the new patents available. So how we can also introduce the same thing among our faculty as well as to the students. So this is very, very important. So I think the PPT is ready, coming up. So please come down to empowering faculty in EC. And also we need to focus on mentoring and guidance. Can you please scroll down?
Deborah ma'am.
For mentoring and
Yes,
guidance,
ma'am.
can you go to the presentation mode in the PPT?
Yes, ma'am. Yes, ma'am.
Presentation mode. F5, I think.
Yes, ma'am. It's done, ma'am. I did F5. I could see here.
Not say there is a symbol down, no, like a cup symbol is there. You have to press that
Yes, yes, ma'am.
down in the last line. Here to the right, near the volume control. Yes, exactly. Is
Is
it
it?
getting presented in the?
Yes, ma'am. Is it now okay, ma'am?
Okay,
No,
go to
ma'am.
the previous slide.
Previous
It's
slide.
not fine, but it's okay. Go to the previous slide.
Ma'am, once again you click on that symbol, ma'am. PPT symbol.
No, no, no.
Ma'am, or else you can press it F5, ma'am. F5 you can press it. It will come to the presentation.
Okay, it's okay. You just come down. Come down to, I think, fifth slide. Come down to fifth slide, madam.
Fifth slide, ma'am.
Fifth
Okay,
slide.
ma'am.
One slide before. Oh, yeah, yeah. Just stay there. So here, role in research and innovation, because this is very, very important for every faculty. So the empowered faculty members are more likely to engage in research and innovative activities. This is mandatory, because unless we do research and update ourselves and bring new ideas, we cannot do justice in this 21st century teaching learning process. So in the department, you can have, we have idea clubs for the students, but we need to have an idea club for the faculty also in the department, which I follow. So there should be something like every day or every once in 2 days, there should be some idea in each specialization. Maybe you take DSP, you take VLSI, embedded systems, or different artificial intelligence or cloud computing or IoTs. You can have clubs for each and everything and bring in new ideas from the faculty, bring the new research ideas, make them write papers. So it is not only when you get an inspection, but it should be done on a very regular basis, because this technological inputs to the faculty is going to help for the students, because they are going to the class, they will share whatever they have found, because all these syllabus whatever we have is available online. You can just get it in a click. But what the students won't get is our experience, what they are going to get from the faculty. So we have to make the class very, very interesting and also valuable, and make the students understand that is possible only when they come to the class. So then the attendance problem also will not be there, and the students also will have interest in coming to your class and learning something. You can also involve them in writing papers. So this research and innovation is a never-ending process. We have to speed up, though it is there, but we have to speed up. And then industry connections, because I do this with my faculty industry immersive program. That is nothing but, see, we have internships, and the students go to the internships, and many of the companies, they don't entertain the huge group of students to their companies. So in that case, what I do is I send the faculty from the department to take the industry training. The reason behind this is, when we send the students, they go, they do the internship, and they leave the college. We don't get any benefit from them to the faculty or from for the existing students. So if the students are able to get internships, let them go ahead. But additionally, we need to send the faculty getting permission from the industry and send them and get updated with what technologies they are using, what are the new advancements, how the industry look like. So they have to do a faculty industry immersion program, come back to the college and make a report, and also deliver that to the students by conducting a seminar or something like a program, a workshop. So that will be very, very effective. So this is how the industry connections should be there, not only to the placement officer, but also to individual faculty. So this will bridge the gap between the academia and the industry. So this is very, very important. Go to the transformative impact on student slide. I will tell you when you have to change the slide, please. So the students' success depends upon the empowered faculty. And then the creating industry relevant experience also depends upon how you're going to design your pedagogy or industry aligned curriculum, how you're going to design. And next slide, institutional impact. The institutional impact, madam, can you go to the next slide? So here, the empowered faculty uplift the overall educational experience, benefiting the institutional academic reputation. So what we do is, what the institution is going to be projected outside. How people will see the institute is based on how we are going to deliver the content and how we are going to polish our students' knowledge and their skill expertise. So this is very, 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 very important, because the institutional impact is only going to speak. That is how even we will get the respect from the public. Then we need to, next slide, ma'am. Continual professional development. We need to have a continual professional development. Next slide, please. Next slide. Yeah. Next slide. So today we are going to touch upon the innovative VLSI design ideas pioneering the future and exploring generation VLSI solutions. So this is very, very important. They may not be in the curriculum, but we need to focus and create interest for the core EC students to understand more about the importance of VLSI. So when we come to this, next slide, ma'am, we all know what is VLSI. So I will just take one slide to mention about VLSI. What is VLSI? So VLSI refers to the process of creating integrated circuits by combining thousands or even millions of transistors on a single chip. This is what is VLSI. We all know very well as ECI faculty. Coming to the next slide, significance of VLSI. Come to the next slide, please. Next slide, please. Yeah. Here, technological backbone. Why it is important in modern technology? So, technological backbone. VLSI is the backbone of the modern electronics. Why? Because it enables the creation of complex, high performing devices. That is very, very important, which the students should know. This is the power. Then miniaturization and efficiency. Already in the introduction, I've told you, miniaturization is something which everybody wanted. They want as minimum as possible, the device size and weight and compact, just like that they wanted to carry. So It facilitates, the VLSI facilitates the miniaturization of the circuits, leading to smaller devices with increased functionality. So this is very, very important that the students should know the value of VLSI. Why I should learn VLSI? Because they also, when they go and buy a cell phone, they'll just check like, it is so huge in size, I don't want to buy this. If you have a compact one which I can just put it in my bag or pocket and go, I'll be happy. So miniaturization is something which everybody is looking for. Then power and performance. So VLSI advancements contribute to power efficient and high performance electronic systems across various industries. So everywhere hardware is required. So they all require that high performance, and also the power efficiency is very, very important. Coming to the next slide. Next slide, please. This is the one which shows the evolution of VLSI. So here, the birth of ICs, integrated circuits, are from 1960 to 1970s. That is medium scale integration and the large scale integration. Then 1980 emergence of VLSI. Then 1990 to present, it is continuous evaluation towards very large scale integration, and also the system on chips designs. Coming to the next slide. Key milestones in VLSI. So here when we talk about, I said in the introduction only, we need to remember the Moore's law. This is very, very important because the Gordon Moore's prediction in 1965 about doubling the number of transistors on a chip approximately every 2 years. Just see how many components are going to come in one single board. Then process shrinking, the shrinking transistor sizes and also the feature sizes, enabling higher transistor density and performance improvements. And also innovations in design tools, achievements or advancements in design tools, CAD software, and the fabrication techniques driving a VLSI evolution. So all these things are the key milestones actually. Then coming to the next slide, specialized VLSI designs. See here, we have to talk about the graphics processing units, GPUs. The originally designed for rendering graphics, that is graphics, they have evolved into powerful parallel processors suitable for high performance computing tasks. And VLSI design in GPUs emphasize parallelism and optimized processing of large sets of data. So this makes them ideal for scientific simulations and also the artificial intelligence and the complex computation. See how this in depth, if we go, we are knowing about how much efficient our VLSI is and how the students have to know about it. Then the tensor processing units, we call it as TPUs. So this is developed by Google. So the tensor processing units are custom built ASICs tailored for machine learning tasks. See now machine learning, deep learning, AI, these are all part of our lifestyle. Everywhere we are hearing those words, and we need to think about in everything because now we are in industrial revolution only for the 50 years of this century. Next, we are going to have a personalized lifestyle actually. So there we are going to work with a lot of machine learning tasks along with the human and robotic combination is going to be very, very high after 20 years of this 21st century. So we have to focus more on these areas. Then application specific integrated circuit, that is ASICs. So they are custom designed chips optimized for specific application or task. Then coming to the FPGAs, field programmable gate arrays. So here the FPGA offer reconfigurable hardware, allowing users to program the chip's functionality after manufacturing. So this is one advantage of using FPGA. So we bring it to our lab and we can program. And also the VLSI design for FPGAs involve creating customizable logic blocks and interconnects, offering flexibility of rapid prototyping, specialized applications, and also hardware acceleration. So these are all some very interesting facts of these things, these parts. Then coming to the Next slide, significance of or significance in VLSI design. So we have already talked a lot about this energy, performance, application specific solutions, innovation and advancements, and so on and so forth. So performance optimization, what do we do in this performance optimization is specialized chips are designed to excel in specific tasks. So that is a specialty, and also it will allow the VLSI designer to optimize their architectures for maximum performance and efficiency in targeted applications. So specifically for application purpose, we can make it performance optimization can be done for every targeted application. Then coming to energy efficiency, I told you already, people will choose this technology because mainly because of this energy efficiency. So tailoring the VLSI design to specific functionality minimizes unnecessary components. See, power consumption increases when you have huge number of components. So here, this tailoring the VLSI, we need to tailor it for one particular application. So when you do that, we can minimize the unnecessary components. So energy consumption also will reduce. So that will lead to increased energy efficiency and reduced power consumption. So this is one advantage which will make people look for VLSI. Then application specific solutions. So these chips enable the development of application specific solutions catering to diverse needs, because we will have n number of needs and applications, and we may have to use in industries for AI acceleration to cryptographic algorithms and beyond. So many things will be there. So we will have the chips that will be developed for application, one specific application solution. That is one advantage. And then innovation and advancement. So the continuous development, as I said, every day some new technology is coming, new innovative ideas are coming, implementation is happening, but we need to update each and everything on a daily basis, because the speed of improvement and increase is going on in a very, very fast rate. So the continuous development of specialized chips drives innovation in VLSI design methodologies and encouraging new architectures and approaches to meet evolving technological demands. So even the architectural modifications are happening. So we need to keep that in mind. Coming to the next slide, art of VLSI design. So what is the art? What do we do? The three steps is, one is creative process. Next is interdisciplinary collaboration. Third one is continuous innovation. This one slide tells us what is that we need to do to become an expert in VLSI design. So first one is creative process. So this involves a creative process of the circuit design and also optimization. This is very, very, very important. Then interdisciplinary collaboration. So this requires collaborative efforts between electrical engineers, computer scientists, mechanical people, different departments. We need to collaborate, and also not only with the engineering discipline, we may have to have a cross functional disciplinary integration and collaboration. So because now all these things have applications in different fields, everywhere they need this. So collaboration with different interdisciplinary, intradisciplinary, cross functional, and a lot of other fields, everything is required. Then continuous innovation. So VLSI designers continuously innovate to meet the ever evolving demands of the modern technology. So that is why I said innovation has to be done even from the teachers, educators, because from there the students will get inspired and they will start looking for a core job. First of all, our students should apply for core job. To get interest to go to the core job, they should know the importance of the electronics and communication engineering. Next slide, VLSI and tomorrow's technology. So coming to the next slide, challenges. Next slide, please. Challenges in VLSI design. So we will run through shortly with this challenges. That is identification of challenges. First one. One is complexity issues. As the chip designs become more intricate, managing complexity becomes a major challenge in VLSI. because we have seen how many transistors, how many components are coming in one small chip, like that becomes the design more complex. It's very, very difficult to handle them. So designing and verifying complex systems without errors becomes an increasingly difficult job. That is one thing very, very, very difficult, because more number of components fall into one chip, verifying the complex systems without errors. So that is the one thing which we have to keep in mind, the challenges. What are the challenges in VLSI design? Then power constraints. The power consumption remains a critical concern in VLSI design, because balancing performance with energy efficiency is essential due to the proliferation of the portable devices and IoT technologies. So here the power constraints have to be, because they are portable. So we have to be careful about how these power constraints are handled during the VLSI design. Then scalability. So designing chips that can scale in terms of, we have to think about the performance, we have to think about the size, then we have to think about the functionality, because these things should not compromise the efficiency. That is very, very important. So performance is required, size is required, functionality is required without compromising the efficiency. So this is a significant challenge. So this is very, very important. Now coming to the next slide. So now we have seen where we have challenge. So now we have to think about how to overcome this challenge. So some innovative ideas are to be collected, are to be discussed among the EC faculty, along these students. So that can be an idea club activity. Okay, we have this challenge. How to overcome the complexity? For example, let me take complexity. What are all the ideas you will give? So that again becomes a club activity, and students will start thinking about it, and they will come to know, okay, we can do, they will get additional knowledge which is not there in the syllabus. So the innovative design methodologies such as hierarchical design approaches or advanced simulation techniques can aid in managing and reducing complexity. So this has to be discussed widely along with the students, so that they will come with a lot of new solutions. Then if you talk about the power optimization strategy, so what is the idea we can give for power optimization? So we have to think about the novel low power design techniques. How do we design with a low power? So that is a novel idea, that is a new idea we have to bring in, and then think about it, talk about it, document it, implement it, and then you will also get confidence. So here what we can do: voltage scaling we can do, power gating we can do, dynamic power management we can do. These are all the things which will address to the power constraint. So in depth, the students should think about what to do, how do I scale voltage, what is power gating, what is dynamic power management. So they have to be given individual topics, and they have to work on it and come and discuss. A brainstorming session can be conducted so that everybody will get a knowledge. And then scalable architecture. So how do we get a solution for this scalable architecture? So innovative architectural designs like modular and reconfigurable architectures that will enable the scalability while maintaining efficiency and performance. See, whatever we do, we have to keep in mind that efficiency and performance should not change. So how do we do? You have to think, sit, and get all the brainstorming ideas, document it, make it as a project, make it as a report. That will be an outstanding initiative, and also that will create interest for the students to work in core companies. Then coming to the next slide, hardware acceleration. What is the innovative ideas we can give for hardware acceleration? So here we can think about the parallel processing architectures. So introduction of architectures emphasizing parallelism or faster computation, because we are going to have parallel processing. We are going to have simultaneously process running simultaneously. That is like a single instruction, multiple data, or multiple instruction, multiple data. So these are all things which will help you for accelerating the hardware. Second one is specialized processing units. So designing dedicated hardware accelerators. So we have spoken about GPUs, TPUs, ASICs. We all spoke about all those things. So for specific computational tasks, they have to use dedicated hardware accelerators. So that will enhance the overall system performance. Coming to the next slide, low power design. Next slide, please. Low power design. So again, we talked about the importance of VLSI is what? Power saving only. So how do we design with the low power? So here we have to think about some innovative ideas like the dynamic voltage and frequency scaling, and then leakage reduction methods. This is very, very important because all the power, which if we make use of it, it is fine, but there will be leakage. So we have to implement innovative circuit design methodologies to minimize the leakage current, a significant contributor to power consumption on chips. So this is very, 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 very important leakage reduction method. So we have to work on where it gets leaked, minimize the leakage and all. Then coming to the next slide, innovative idea on emerging technologies integration. So now this is the need of the hour because 21st century we have all the latest technologies. So how are we going to integrate? First one is AI integration in VLSI design. My dear ladies and gentlemen, this is the area. This slide is very, 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 very important. We need to focus more on how are we going to integrate. So leveraging AI and machine learning algorithms for automated chip design, optimizing layout, and also enhancing design productivity. We have to learn and research a lot on AI integration in VLSI design. Of course, we have to learn a lot, but with the input of the students, I think it will make things very, very easy. You can just split the topics and give them as assignments. And then quantum inspired computing. I told you quantum computing is going to be the future. So exploring quantum inspired algorithms and architectures in classical VLSI design for improved performance and efficiency. We can also invite the physics faculty who can work on quantum computing because it is their area. So we can have a collaboration with them and then get some ideas from the physics faculty about the quantum computing so that we can work more on that. Coming to the next slide, application specific solutions. As I told you about this, that is ASICs. Designing ASICs tailored for specific industries or tasks, optimizing performances and power efficiency for targeted applications. So specifically, like how we have the biosensors, we have a targeted drug delivery. Wherever you wanted to kill some cancer cells, we will have a targeted drug delivery. In that part alone, we will do. Similarly, in ASICs, we can have some applications where we can have some tailored only for that particular application we can design, and also customizable platform like FPGAs. So these are all some things which will be useful. Go to the next slide, ma'am. The future of VLSI. So here the advancements of VLSI have incredible influential. It's going to have a huge influence on the 21st century. So here some of the cutting edge applications. Let me just run through. Next slide, ma'am. AI and machine learning acceleration. So here, this is very, very important because we cannot eliminate AI from our life, and machine learning, of course. So how do VLSI technology is driving the advancements of AI and machine learning through innovation and efficiency. So this is future. Next slide. We have neo-marking computing. So what is this neo-marking computing? Here, first, we will talk about the mimicking human brains architecture. So artificial intelligence itself is that only. It is just trying to behave like us. So mimicking human brains. So neomorphic computing involves the VLSI-based designs inspired by the brain's neural networks. See, how important this particular example when we talk about mimicking human brain, the brain's neural networks are to be designed. So neuromorphic computing involves VLSI-based designs inspired by the brain's neural networks, aiming to replicate their architecture. So however we are thinking, however we are working, the same thing will be replicated using our VLSI architecture. And it also emphasizes the use of spiking neural networks and also event-based processing for efficient data handling. So coming to next slide, Edge AI. This is another very important thing. Next slide, please. Edge AI. So here, low power chips, privacy enhancement, and reduced latency. So low power, high performance chips. VLSI design enables we have discussed a lot about it, the creation of chips tailored for edge devices, focusing on low power consumption and also high computational performances. So this is a very, very important area where VLSI will be made use of. Coming to the next slide, dedicated AI hardware. So we already discussed about this tensor processing units. We have discussed about the GPUs and specialized AI hardware, VLSI design for TPUs, we know, and the performance efficiency we have discussed. So all these things are going to have a dedicated AI hardware learning. So application specific chips we discussed, ASICs, and also enhanced performance, how we can have an enhanced performance with this dedicated AI hardware. Next slide, efficiency and innovation. So efficiency data processing. So VLSI enables efficient and high speed AI data processing. So how VLSI is going to give you efficiency and innovation? We have already seen VLSI enables efficiency and high speed AI data processing. So that is one advantage why VLSI can be integrated with AI. Second one, innovative architecture. So it allows the development of innovative hardware architecture for AI tasks. So with VLSI, we can have innovative architecture specifically for AI applications. That is one more advantage. Third one is energy efficient computing. So here we have already seen that power consumption can be taken very well with the VLSI. So enables energy efficient computing for AI applications. Next slide, please. Future of AI hardware. Come to the next slide, please.
Previous
Okay.
slide, ma'am.
Yeah, previous slide. Future of hardware, AI hardware. Previous to previous.
Yes.
So here we can see the advancements, enhanced capabilities, and optimized performance. This is that AI hardware plays a major role because AI application is spread over the entire field. Whatever field you take, AI is required. And for this AI hardware, VLSI is going to add lot of value because VLSI technology is set to drive significant advancements in AI hardware because we have seen a lot of specifications relevant to the VLSI which can contribute a lot for the future technologies. And enhanced capability, we know the capability of our VLSI, so anticipate the development of AI hardware with enhanced capability. Suppose we use the VLSI design in creating a AI hardware, definitely we'll have enhanced capabilities. Then you can also expect optimized performance and efficiency in future hardware. So all these things make us understand how VLSI will add value to the future of AI hardware. Next slide. AI acceleration technologies. So here, first one is advanced microprocessing. So VLSI's contribution to advanced microprocessing, if you see this, VLSI technology enables the creation of high, complex, and powerful microprocessors through miniaturization and integration of multiples of millions of transistors on a single chip. So here, why VLSI is preferred or why VLSI is very suitable is contribution to advanced microprocessing. Here we have the capability, we have the facility, and also we can focus on enhancing processing capabilities. We can also improve how quickly, that is what I said, when quantum computing come into picture, the speed of computing will be increasing. So when we merge, when we collaborate all those things with our VLSI, the speed can be increased, functionality can be increased, processing capabilities can be increased. So this is the main reason why the acceleration technologies, like AI acceleration is possible when it integrates with VLSI. And then the infrastructure development also here, VLSI advancements form the backbone of AI hardware infrastructure, providing the foundational elements for robust AI systems. So that is possible with our VA because it focuses on designing hardware components optimized for AI workloads. So that is why that will be tailor-made. Hardware can be given for AI applications. Then efficiency enhancement. So here the VLSI technology drives innovation in hardware to enhance the efficiency. Lot of work, research is going on in making the VLSI order much more better and efficient. So that speed is going to help the AI hardware to function or do better output, give better output for its application. So here these all come to a conclusion that VLSI is going to give a very good solution for AI hardware for its excellence. Come to next slide. So some more new technologies where this VLSI is going to be helpful is 5G and beyond. So we have been, as EC people, we are all very aware of 5Gs, and here also we have a lot of requirements. First one is RF chip design. So VLSI expertise is crucial in crafting RF chips operating in high frequency bands. So we all talked about when we get 5G, then IoTs are going to be in every place. We can have an IoT home, we can have an IoT smart home or smart city. Everywhere we can have IoTs because of its higher frequency bands. It works on higher frequency bands. So this RF chip design with the VLSI expertise will enable faster data transmission and lower latency in 5G networks. And millimeter wave technology. Here, VLSI plays a role in designing the chips that operate in millimeter wave frequencies. So that is also, that will enable the high bandwidth and I can say ultra fast communication. Ultra fast communication essential for 5G infrastructure because 5G itself requires a fast communication. So these things, millimeter wave technology will help to attain that requirement. And then multiple input, multiple output, that we call it as an MIMO. So this massive MIMO is backed by this VLSI advancement. So this will enhance the spectral efficiency and also the data rates in 5G networks by employing numerous antennas for communication. So massive MIMO is also going to be there in future. Next, coming to the next slide, IoT and wearables. Coming to the next one, IoT and wearables. Again, see, we are talking more about the low power design. This is what is the highlight of VLSI, okay? Low power design. So VLSI techniques enable the creation of efficient, energy efficient chips. I can call it as energy efficient chips, which is crucial for extending battery life because IoTs, sometimes we will have somewhere where we don't have the power facility. So there the battery life is very, very important. So this high efficient chips, what we use using the VLSI techniques will help to save the power. So extending the battery life in IoT devices. Then the sensor integration. So the VLSI allows for integration of various sensors because sensors, without sensors, no IoTs and no artificial intelligence, or everything is on sensors only now. So VLSI allows the integration of various sensors on a single chip. So this facility of development of compact and multifunctional IoT is a sensor integration plays a major role with the VLSI devices, and also connectivity solutions can also be brought in. Then coming to the next slide, quantum computing and quantum communication. As I kept on telling from the beginning, quantum computing is a need of the hour. Whichever university is going to take quantum computing as a very important topic and conducting lot of seminars or workshops or FTPs, and also making the students and faculty write papers on quantum computing and also take up the research ideas on quantum computing, are going to rock like anything because this is what is the future. So quantum circuit design is one thing which we have to work on and learn a lot, because VLSI plays a key role in designing circuits for quantum computers. So quantum computing is going to be the future, And VLSI from EC, that is going to play a key role in designing the circuits for quantum computers. So controlling we will have something called as qubits in quantum computing, and also some quantum operations will be there. High speed, it will be very high speed, it will work. So major thing working with that is VLSI. So we have to learn that in association with the quantum circuit design. We have to design in such a way that VLSI is used for quantum operations. Then error correction. So advancements in VLSI are essential in developing error correction mechanism. That is very, very important for stabilizing quantum systems. That will pave a way for reliable quantum computing. See, you will remember, if you see next generation or coming shortly, when people talk about quantum computing, because that is going to be that is happening as a very big research in ISRO, NASA. Every big research institutions are working on quantum computing. So when we also take up that and do it as a research work, then it's going to rock. Even the students can do projects on quantum computing. And even the first year students, when they study the science and humanities in the physics, you can give them a talk on quantum computing, write some assignments on quantum computing, publish a paper on quantum computing. So the first years, when they come to the final years, they will really they will see how quantum computing is working. So they will be aware of it. So this way you can make your university students also abreast with the new technologies, whatever is coming. And then coming to the next one. Biomedical devices and health tech. So biomedical, see, when you talk about the career guidance or the career which are of high demand, I can say healthcare. Healthcare is the number one need of the hour. So not everybody can become doctors or other allied courses, but as engineers, especially as EC students or graduates, they can get huge opportunities in healthcare sector, where they need the knowledge of how to integrate with the medical area field as well as with the devices used by them. So here, this is we talk about the implantable devices. Actually, my research work is on biosensor, biochips. Actually, it can be implanted in the body and it can sense the diseases, and it also have automated automated disease detection and also drug delivery. So this I did in 2008. But now that is the need of the hour. That is rocking like anything, the need of the hour, where people wanted to work more on the implantable devices and cure the devices, because the ratio requirement of the hospitals and doctors compared to the population is very, very less. So when we don't have a particular, for each patient, we don't have a doctor, we are looking for an implantable device which will diagnose your disease and also give you drug, so that small things can be rectified without going to hospital. So this is even not only that, because my research work was focused on cancer detection. So the we come across knowing about the cancers only in the third stage or final stage. But this device, the implantable device, once it comes in practical, it can detect from the first cell which erupts in your body. So that can save many lives. So in implantable devices, VLSI enables the creation of miniature, because when you implant something in the body, it has to be smaller. It has to be very, very small. Only then you can implant in the body. So this VLSI enables the creation of miniaturized low power chips for implantable medical devices that is used in monitoring the treatment within the human body. So when it is there, it will keep monitoring. So low power devices is required, isn't it? So for all these things, VLSI will play a major role. Then high resolution imaging. So VLSI advancements contribute to creating images or imaging chips with higher resolution, aiding in precise diagnostics and medical imaging technologies, and then the point of care diagnostics. So this POC is also widely spoken among everybody. So VLSI plays a role in developing portable and cost-effective diagnostic devices for immediate health assessments. So these are all something very, very important. And coming to the next slide, automation, automotive innovation. Next slide, please. No, no, previous one, previous one, previous one, previous one, previous one. Automotive innovations, that is sensor fusion. So sensor fusion and this ADAS, VLSI is a crucial, is very crucial for integrating sensor data in real time, because as we talked about 5G, we are going to have a lot of sensors, and a lot of sensor data is going to be received and transmitted. So we have to collect the sensor data in real time and enable features like collision detection, lane keeping, adaptive cruise control in many automotive related applications. This is very essential. And second one again, why this is preferred is power management. Then connectivity solutions are easy with the VLSI. Next one. Environmental sensing and sustainable technology. So here again, it can be used for, so when sensors are there, environmental sensing is also one of the very, very important area which we have to keep in mind. So this VLSI enabled sensor networks monitor environmental parameters. You know, we need to monitor the air quality, we need to monitor the temperature, we need to monitor the pollution levels. So all these things are required for environmental conservation initiatives. So for this again, VLSI is very essential. And also next is data analysis. So when we have sensors, when we have 5G, when we have a lot of data collection from sensors, data analysis is another area where we have to be making use. Why we are making use? Because we need to take decisions based on the data we collect. So all these things are very, very essential. Come to the next slide, ma'am. So in the 21st century, the very large scale integration technology continues to evolve, impacting various domains. What are all those domains? Next slide. Artificial intelligence and machine learning, Internet of Things, 5G and communication technology, healthcare and biomedical devices, automotive industry. Next slide. Environmental sensing and sustainability, edge computing and edge AI, high performance computing, security and cryptography, entertainment and consumer electronics, energy management and efficiency. We have spoken about all these things in the session. So this is what is going to be the future where VLSI is mandate. So we have to focus more on the VLSI design and understanding the latest challenges and the new architectures required for AI integration and also for the new technologies, and involve our students and faculty on a daily basis so that the core industries are going to welcome them, and also they will be placed in very good positions when they have awareness about the futuristic advancements in technology. So next slide, please. Thank you so much for your patient hearing. Because it's in a very short period, I just had time to just throw light on what is the need and where we are and how important VLSI is. So thank you so much for the opportunity.
Thank you, ma'am. Thank you very much.
Thank you.
Lakshmi Narayanan, sir. Over to you, sir.
First of all, I must thank Dr. Ushaa Eswaran for being patient enough to have a lecture on empowering the faculty easy regarding how to enhance the VLSI design process and its applications. Ma'am, thank you, ma'am, on behalf of the department. First of all, I would like to express my sincere thanks. And what I want to ask is um, regarding curriculum enrichment. What are the topics that we can incorporate in VLSI design as far as our UG curriculum is concerned? So we are simply studying VLSI design. So is there any specific topic that needs to be incorporated in the syllabus? I mean, either as a coursework or as a part of any course material.
They need to first of all know about the basics. Basics is one thing which is very very mandatory. So you can have, I mean, specifically add-on courses can be had, but apart from that, basic concepts in VLSI design is very very important. And then you can include digital design and logic synthesis, not only as a theory but also practically. Then analog and mixed signal design you can have. Then VLSI circuit design techniques can be added. Then see, when we go for PCB, we need to know about the physical design and layout, so that can be done. And you can also have a hands-on workshop or a session on testing and verification. And you can also go on some advanced VLSI topics. And you can one more thing which you can do here is the case studies. Students can submit a project report on case studies that will help them to understand what is going on, what has been done so far, what are we supposed to do. And also they can interact with VLSI industries and also discuss with the people on what they are working on, what are the lab facilities required, and what is that student should know if we have to work in a VLSI industry. So that industry curriculum can be taken from in the VLSI industry and added as an add-on course or as a main subject.
And one more question, ma'am, I want to ask you. Uh, how far the smart materials are being useful in VLSI design? Uh, we have come across smart structures, smart materials. How far these smart materials are being related to our VLSI design? Is there
Sir,
any correlation?
of course,
Shall I?
sir. Sensing and actuation, something like the piezoelectric materials, they will be useful actually. So these materials, they'll be offering, they'll be responsible for enabling innovative sensor designs and all. So piezoelectric material, and then tunable components are available. Tunable components can be studied actually. The materials with something like a controllable properties like ferroelectronics or magnetostic materials like which are integrated to VLSI. Definitely, they need to know about the components and the materials. Then energy. When we come to energy again, they need to know about the smart materials. Again, the piezoelectric materials, they have the capacity to convert the mechanical to thermal energy and into electrical energy. So there again, the energy harvesting can be done. And flexible electronics, you know that smart watches or whatever, you can even paste in your hand. So that flexible electronics, again, the smart materials come into picture. And also something like self-healing materials. Self-healing materials, in specific self-healing materials, I don't remember the name of that material. So these are all the materials which are mandatory for the students to know about, the smart materials.
Say, what are all the materials that need to be learned, their properties, if I want to pursue a career in a VLSI design engineer? Regarding, I'm just talking about the chemistry and geometry of that material. What are the materials now? A lot of earlier it was only germanium and silicon. Later on, a lot of material gets added to it. That's what I'm asking. Is it only germanium and silicon now, or any other materials that we are using?
Semiconductor basics they have to learn, and then digital electronics, analog electronics. You are mentioning about you want specific materials, is it? Material
Yeah,
name.
germanium and silicon are commonly orginium. All these things are quite well known. Is there
Okay.
any new material
New
being
material.
used?
Give me some time, sir. I will get back to you on it. Right now, I don't have an idea about it.
Okay, okay, ma'am.
Okay. I'll get back to Rambabu, sir. I'll let him know once I read some material.
Definitely,
From,
definitely. So, audience, if you have any questions, you can ask madam. She's ready to answer you.
Uh, yes, sir, I have a question. I'm Professor Dinesh, calling from CSNSIS Chhatrapati Sambhajinagar, Maharashtra.
okay.
Sorry for the background disturbance. Madam, just a while you discussed about this professional improvement.
Mm.
So can you please a bit, if you can elaborate that point?
1 minute, sir. I'm getting a call. One. Sir, please come again. What is the question?
Yeah, madam.
Professional?
Yes, you were discussing about that continual professional development.
Yes, yes, yes.
So, if you can please elaborate that point.
Continual professional development for EC faculty or any other department faculty is innovation only, creativity, innovation, learning about what's happening. So that will only make you professionally grow. So when we start writing papers, attending conference, workshops on latest things, not on again talking about the existing ones. So conferences and workshops on latest technologies is going to be very useful. And if you can't go some online courses and certifications, research publication is one thing which will write books. You can write chapters for books, and also you can have a session where you read about other people work. Then there are so many professional associations and societies are there. We can become a member and then attend those sessions. Webinars will be there, conference will be there. You will also have networking opportunities with those people. And also we should talk about the pedagogical training, like how the teaching methodologies should be utilized. If it is teacher centered, then we will be talking and students will be listening and they will not learn anything more. So how do we involve the students? You can have a flipped classroom. So one day before you can give a topic and ask, make groups and ask them to come and present the next day. Even our professionalism will improve. We will also learn a lot from the students because we don't know where they are bringing from. They have a lot of sources than us. So that will be additional. Then industry collaboration, as I said, faculty industry immersion program is one thing which my faculty people are very, very happy, and they are able to get a lot of industry updates. So we are sitting in the classroom, we are in the university with the syllabus what we have studied and with the little advancements in the new curriculum, but we are not reaching the industry, what is happening in the industry. So there we have to visit industry, we have to talk to the people, maybe in a lab or research, in case of core industries, and then come back and conduct an FDP for at least for your own faculty and share about what they learned from. That is a professionally you will be growing, you will have better learning compared to other teaching faculty in other colleges because they will not do this practice. And also there should be a peer learning, one to one. There should be best practices in your college, where you best practice in any institution should be towards research and innovations. In this you can also include students that will add value to the quality education. So this is you should have a professional development plan, sir. In a day, you have a if you have something like 24 hours, how much time you are going to allocate for your professional development? We
Right.
all work for the college development. You work for the NAC, you work for NBA, NIRF, all these the committee work, and you're writing documents and filing the documents. That is mandatory. But you should also allocate minimum 1 hour for your professional development. So what you are going to do is your design. You have to decide what is that you are going to do and how you are going to improve your professionalism. So when you allot 1 hour or 2 hours, you can make a time table or a what to, time box calendar. So okay, Monday, which hour? Maybe that day you don't have classwork or you have only lab in the afternoon. Morning you have 1 hour. Allocate it for your professional development. So you can list what all as what I do. I will tell you. So first thing is every day I will read the latest. So any magazine or any online medium or anywhere, you can take one particular area and browse what is that has happened today, how many people have been working on this area, what are the new things they have found. So this you can have a notebook where you can keep noting on, okay, this day I have learned about this, and a link also whatever you have learned. Try to enhance that to extend it as a paper. I do that. If I learn about quantum computing, then I do a lot of research on it and take a literature survey on what has been done so far, and also add value to that. At least as a review paper I used to publish. So in that, like you read 10 papers, you gain some knowledge, come back to college and discuss among your faculty, your department faculty, whoever, one person or 10 people, whoever is interested, or bring students, and in the class you talk about it. At least through you, one person will get that interest, and when you teach, you learn more. This is my practice. And then you can also think about, okay, today I'm going to read, today I'm going to write, today I'm going to share, today I'm going to teach. So your plan based on your time slot, but every day minimum 1 hour you have to spend on your professional development. There are so many book chapters which are being asked. You don't have to write a complete book. At least a chapter on some topic you choose, work on it, learn more from it, gather a lot of information, and then you think about what input you can give to add value to that content, and send to them. The reviewer will give you some comments. Okay, you have to improve on all these things. So again, when you implement the reviewer comments, then you become more professional in that area. So this is how we have to keep some time for our professional development, and your resume should be added with new professionalism, whatever you have brought in. You have written a paper, you have shared a session with somebody, you have a speaker in a forum, you are an attendee in a forum, or you have taught something for your students, you've done a project with the students. You have to keep adding in your resume what all you are doing. Then one day, after 1 or 2 years, you yourself will feel, okay, I've grown this much. The problem with our faculty is we say we don't have time because we are already having a lot of work in the college, and we dedicate entirely for the college, and we forget about our personal growth. So you have to be a little bit selfish on improving your professional life by doing all this activity. It is not difficult at all. Like you can keep doing. Once you start doing, it will become a habit. You'll start enjoying it, and it will become an addiction also for you, that every day after coming home or in the morning, you start reading something, writing something, make a document on whatever you do, because tomorrow you cannot search for it, you may not get it. So everything should be documented along with the links, and try to think about it also more, discuss more. When you discuss more, you understand better. That is what I experience.
Yeah, madam. Thank you so much for getting into that deep and such a profound this sharing. Thank you so much, madam.
Yes, sir. Thank you so much.
Ma'am, I have another question regarding curriculum. Ma'am, actually, we are planning to start a BTech VLS
Okay.
design. Is there BTech electronics engineering? with specialization in
Okay.
Vlsi Design. So as ICT has recently promoted this as a part of Make in India campaign, because we want to locally hire people, we want to increase the local manufacturing of semiconductor industries. So we are planning to um, have a course in electronics engineering with specialization in VLSI design. What are the areas that can be improved upon apart from our regular electronics and communication engineering subjects? So
Uh,
any
yeah.
specific subjects
They need
already
to
they have
know basic
guidelines?
sciences for sure. Mathematics, physics, chemistry, these fundamentals relevant to semiconductor physics. Don't make it in general. Don't make it a general maths, physics, chemistry, because our students, whoever is studying maths, physics, chemistry in the first year, they don't know why they are studying. They don't have a link between why they are studying and how it will be useful in future. So without that, you need to have a link with the semiconductor physics and material science. First thing is maths, physics, chemistry fundamentals relevant to semiconductor physics and material science. That is mandatory. Then we also need basic electrical engineering for these people. So they need to know what is circuit, they need to know what is signal, they need to know what is a system. So this is mandatory. Then you can have, because it is a BTech curriculum, they also need to know basic electronics. So there itself, you can bring introduction to basic electronics and VLSI. That is one subject where they will be talking about the electronics covering diodes, transistors, the basic circuit analysis, everything. And there they can have an overview of VLSI design, and they can also learn about the semiconductor technology and CMOS fundamentals. So CMOS will also, they will get it in there. Then definitely we need digital electronics. Digital electronics and logic design is one subject which they have to learn, because you need Boolean algebra, you need combinational logic circuit, sequential logic circuit design. So that STLD, whatever we have, switching theory and logic design or digital electronics is mandatory, because they also need to know about the register and the trans RTF, RTL also they need to learn. Then you need to have analog also they need to know, because analog signal design also they need to learn. So their ADC, DAC conversions, like linear integrated circuits we have, no, in LIC we teach about the conversion and all that also they should learn. Then coming to the circuit analysis, they need to be a practical class where they need about the circuit analysis and electronic design. They need to be taken to a company where PCBs are developed, how the PCBs are done, how PCB software, there is a software for designing PCB that should be there as a lab. So these people should design the PCB design and also go to a company where PCBs are manufactured, and there they should know how the components are placed. So all these things should be practical or a project work. We have to go. Then you can bring in the VLSI design and methodology. So there that VLSI design will come in either third year it can come with the VLSI design methodology. So there you have to teach about the CMOS technology. Again, when you're bringing CMOS to your lab, you should know how to handle the CMOS chips and devices. So you should have those things, like you cannot touch the pin of a CMOS immediately, it will get short circuited. So you have to have the safety handling the CMOS devices. These preliminary classes are to be told. So VLSI design and methodologies is very important. Verilog should be taught to them. VHDL should be taught to them. And then physical design and backend process is very essential. So the something like, as I told you in PCB and all, like floor planning, placement, routing. For this separately, you should have a laboratory session plus an industry visit. They have to go, and physical verification of the design and how it can be manufactured. What are all the challenges they will have in manufacturing? How small the size is? So this type of laboratory sessions, it should be purely laboratory. And then you need to have a testing and verification. You can have a center from any of the core company in your university, where the VLSI company will come and establish their lab. And because we cannot establish the lab, they are very typical and they need to be done by the VLSI industry people only. So that can be planned, and you can have a center of excellence from a VLSI core company. So that will help you. Then coming to the third year, second semester or something, you can have some advanced VLSI topics. And coming to final year, you can have internships, you can have projects, and I think you can also have a project in second year one project, third year one project, and final year one project. So when they have this practical experience on the VLSI core companies, I think they will be able to learn more from UG degree of VLSI. I don't know. Just like that, I'm just trying to give you an input. We have to work and design. Sit, plan, and design.
Okay, thank you, ma'am. Thank you. Any other questions from the audience? Any faculty members? Hello.
Yes, sir.
Listening? Rambabu sir?
Lakshmi sir, you can go for vote of thanks, sir.
Okay, okay, okay. Yeah. On behalf of the management, the department, I would like to express my sincere thanks to Dr. Ushaa Eswaran, who, as an academician, I can know that how engaged she must be. So, despite all these difficulties, she has overcome all these things, and she has spent almost 2 hours for us to have a lecture on empowering EC faculty regarding VLSI design. So, as mark of respect, we extend our sincere thanks to her. Thank you, ma'am. Thank you very much.
Thank you.
And we know pretty well that VLSI design is an emerging area, and the government of India has initiated to set up manufacturing facilities here. They have started setting up a micron facility at Gujarat. Recently, they have signed an MOU with Micron of USA. So one of our speaker is from Micron. I think she is about to share her expertise possibly tomorrow. So I hope that all of you might have learned the nuances of teaching. As an academic fraternity, all must heed to the words of our guest speaker, Dr. Ushaa Eswaran. So hopefully this will be an icebreaker for all of us. So I extend my sincere thanks to all the participants who have been actively engaged in this faculty development program despite their busy academic schedules. Thank you, one and all. Thank you.
Thank you.
All the participants are requested to fill the Google form for the attendance and feedback. Thank you. You can close. Wait, my participants there are keep on.